Thanks for joining me. We have a smaller room, so that means everybody has to be louder with all of the cheers of applause that you're going to be giving me later. So just keep that in mind. What I'm going to talk about today is the new stuff that we've been working on for YUI Test. So there's a bunch of new tools. Just out of curiosity, how many people have used YUI Tests before in the past? Half the room. Hey, that's not that bad. Although you three rows are a little disappointing. So we'll have to work on that. So the bad news is this is my second talk of the day, so I used up all my good jokes already. So the rest will be bad. It doesn't mean there won't be jokes. They will just be bad. So to start, I also discovered in my last talk that if you turn this on, it works much better. So to start, I want to get this out of the way because I know it's going to happen. Right? This is not me. Though I can understand the confusion. But just to prove that it's not me, we have different Twitter accounts. So you can go and follow those, and you can see nothing at all alike. Okay? So this is a little bit about me. My actual job, the job that I should be doing right now, and people are probably disappointed in me for not doing, is I'm the principal front-end engineer for the Yahoo homepage. I'm also the contributor to YUI and the creator of YUI Test. And I've written and participated in a bunch of books at the bottom here. You can use the coupon that you got in your little bag to go and pick this one up. Highly recommend it. I've read it cover to cover. So I just want to take a step back before we talked about the new things that are happening and talk about how we got to where we are today. So how did YUI Test start? What's going on? So YUI Test debuted a little over 3 years ago, right, with YUI 2.3.0. And before that, I'm going to test the cameraman's skills. So before that, it actually started as a weekend project of mine. So I was pounding away on some stupid little JavaScript thing. I think it had to do with like array extras or something. I don't know. And I had a page where I had a bunch of stuff, and I kept like reloading it and popping up alerts, right? Hey, it worked. Yay, it worked. Great, it worked. I was like, oh, man, there has to be something better than this. And so when I went out and looked on the interwebs, all I found was JS Unit. And immediately I just kind of went, I don't like that. And I had just gotten familiar with YUI. I had been at Yahoo for a few months. And I thought, you know, there's enough little things in YUI that should make it really easy to write a unit testing framework. And so I went home one weekend, and I banged this out. And I came in on Monday, and I sent it out to one of our internal lists and just said, hey, like this is something I worked on over the weekend, just wanted to share, whatever. And Adam Moore from the YUI team responded and said, hey, we actually need a unit testing thing for YUI. Like, let's chat. And so this first edition was basically the result of Adam and I kind of brainstorming about what a unit testing library would look like for use with YUI, and debuted in July 2007. So after that, looks like I'm a little bit cut off there. December, we added a few more things that it seemed like were missing through both the work with the YUI team and my work at that time on my Yahoo. And so that's when I went back and added async testing, so the wait method that allows you to wait for things to happen and then check later on. And the test reporter, which allows you to get your results and then submit it back to a server somewhere. And then XML and JSON test formats. So that was necessary for the test reporter to be able to serialize the data and send it back to the server. So that was pretty cool. And then we started a little bit of evangelism. So I did this talk called Test-Driven Development with YUI Test. It's available on the YUI Theater, so you can go and check that out afterwards. It's just an introduction to test-driven development in general and how you might apply it to JavaScript using YUI Test. And then I wrote a couple of blog posts. First was getting started with YUI Test on the YUI blog, writing effective tests, so digging a little bit deeper into what makes good tests. It was pretty cool. And then with the YUI 3 release, I ported it over, and I added a couple of things. So one was mock objects. How many people know what mock objects are? Oh, a lot of people. Awesome. Cool. So added that in because that was something that seemed to be like really missing, especially my work on the home page, I found that I really needed this. And then also added these friendly test names, which I'll describe a little bit later. And then Ron Adams, who works for Yahoo Sports, did a talk at last year's YUI Conf called Automated Integration Testing. Goes all the way over here. With YUI Test, which was really great. Unfortunately, I was otherwise indisposed. I couldn't see it. That's also available up on the YUI Theater. Highly recommended. And that sort of kicked off the next phase of development for YUI Test when we're talking more about automation and continuous integration. And so in April of this year, I actually did a little survey of a bunch of groups that were using YUI Test for their testing and tried to figure out some of the gaps that were there. And a couple of them I found were basically hooks for automation. So things where you could grab stuff off of the test runner and actually be able to figure out what's going on. I'll talk a little bit about that too. And then JUnit and XML and TAP formats for the unit testing results, because there are a lot of tools available for both of those formats, and it just made sense. If we could present it in that, you could use a lot of the tools that you're probably already using. And then Yeti was released in August. How many people know about Yeti? It was Reed's tool. It's cool. Go ahead and check that out. I'm not going to talk too much about that, but if you go and check out yuilibrary.com under labs, there's this cool tool called Yeti to help you do a little bit of automation with your testing. And then today, yeah, very awesome. So what am I going to talk about today? Basically, three things, three new tools to share. So one is the YUI Test standalone library. And two is the Selenium driver to integrate with Selenium. And third is a code coverage tool for your JavaScript. And I'm going to talk about each of these separately, so don't get worried that you don't know what Selenium is. We'll talk a little bit about that. But just to start with the standalone library first. This was a little bit controversial. So when I first went to the YUI team and said, hey, I want to basically extract the core of YUI Test into this standalone library, so I don't need to load YUI 2 or YUI 3 on the page. I just want it to be there completely on its own. So that's what the standalone library is basically YUI Test without any YUI dependencies. As it turned out, when I was going through this, there really weren't all that many dependencies. There wasn't a lot of tight coupling between YUI Test and the core YUI library itself. So this was actually not all that difficult. So why do this? So there was a bunch of problems that kept coming up periodically that were just really bothering me, and I wanted to fix them. So the first problem was inconsistencies across the versions from YUI 2 to YUI 3. So YUI 2, we had all this nice stuff. This is the old, very verbose format of YUI, and there was a lot of thought about what namespace to add things to. So we ended up with this weird mix where we had a bunch of stuff on yahoo.tool and then a bunch of stuff on yahoo.util. And that always really annoyed me. It just seemed like everything that you're using together should just be together. And then you had like YUI 3. So we put most of the stuff on y.test, but then we hung some of the stuff just on y, which again seemed a little bit weird. Right? Like, why isn't everything just on test? And then to make things even weirder, I ended up with this weird situation where there weren't exactly one-to-one mappings. I won't go too much into why that happened. But we ended up with things that were in YUI 2 that weren't in YUI 3, and things that were in 3 that weren't in 2. And I was trying to figure out in my brain some way to reconcile these differences. So basically, the YUI Test standalone library takes the union of all the features that were in 2 and in 3 and combines them all on this global YUI Test object. So it's pretty much, if you've used either the 2 or the 3 version of YUI Test, most of this should be familiar to you. So there's still like test case, test suite, test runner, reporter instead of test reporter, because it seemed a little bit redundant. Page manager instead of test manager in YUI 2, just because that's a little bit more descriptive of what it actually does, is manages these test pages for you. Test format, the asserts, and then mock. So everything is there from both of the versions just in one library. So another problem I ran into periodically as I was giving talks is people would say, I really like YUI Test. It seemed like there's a lot of cool stuff in there, but I use jQuery, but I use Dojo. And I'd like to use your thing, but it seems like you need to use YUI in order to do that. And no matter how much I tried to convince people, that you could use YUI Test to test anything that you want, this was just a mental hurdle that people were having trouble getting over. Is no, I need to be using YUI to use YUI Test, which is kind of a bummer because there was an article that came out, I think it was last year. It was basically this guy said he's using YUI Test, he's using the Jack mocking framework, and he's using that to test jQuery code. And so clearly some people were aware that you could actually use YUI Test to test any code that you wanted. But there was this little mental hurdle of some people that just didn't want to load YUI onto the page in order to use the testing framework. I said, okay, so I'm going to help those guys out a little bit. So this is also a problem, right, when everyone else is doing it. So this is me jumping off the bridge because everybody else is doing it. So when I first came out with YUI Test 3 years ago, there wasn't much interest in JavaScript testing at all. Like, at all. There was like JS Unit, and then there was YUI Test, and then a few things started to pop up after that. But what happened is there was a shift. So initially, all of the JavaScript libraries were coming out with their own unit testing frameworks. That's how it all started. So QUnit tied to jQuery, the Dojo object harness for Dojo, YUI Test for YUI. That's how it was at the time. Since then, the trend has been towards standalone tools. So you have stuff like QUnit actually removed all of its dependencies from jQuery, so you can use it for anything now. I thought about doing this first. Let's just get that out there. And then they copied my idea that I hadn't yet presented or talked about. It's just the way that it happened. But there are a lot of these standalone libraries that are coming out now that it seemed like in order to compete, that this was the right thing to do. And in talking with a bunch of people even outside of Yahoo, they're like, yeah, we really like stuff like vows or Jack, the mocking framework, and all these things that you could use in a bunch of different contexts. And I wanted YUI Test to continue to grow and to continue to compete. So I jumped off the bridge too. So what does it look like? It's pretty much what you guys are used to if you've used YUI Test for YUI 2 or 3. It's just test case, name, your tests. These are the friendly test names it's talking about. This should work. And hopefully it does. I'm asserting if true works. There's a little code humor in there. But it more or less looks the same. Right? And then you have test suites, which you can add a bunch of test cases to, and then add it to the test runner and then run it. Nothing too revolutionary. I really wanted to make sure that the syntax remained as close to what everybody was used to so that it would be an easy transition if people decided to use this. But this isn't just the port. I also tried to fix a lot of the things that have annoyed me along the way that I just didn't have time to fix. So one of the things that turned out to be a problem was methods on this object assert object. And the problem ones are the ones at the top that I have crossed out, which are now deprecated, but are still there. So R equal was this really weird method that I don't even remember why I wrote it. It seemed like a good idea at the time, but in practice turned out to be really bad. And this was basically you pass in an object that has a bunch of properties and values, and you compare it against another object, and it goes through and it compares not just the property names, but also their values to see if they're the same. But the problem with that was I didn't initially put in a own property check, so it would also be doing things on the prototype. It was also a question of, well, what if that object had all the properties and all the values of this object, but it also had additional properties and values? Should that pass? So it seemed like there was way too much insecurity around that method. So I figured I'd just deprecate it, figure out something more logical later. Still trying to figure it out. If you have ideas, feel free to shoot me an email. HasKey and HasKeys were ones that just checked to see if keys existed on objects. These I removed because there was actually some confusion in YUI 3, where initially the y.object.hasKey method included prototype properties. And then it was changed so that it only included own properties. And then the meaning of HasKey and HasKeys and object assert also changed because it had a dependency on the YUI method. And that caused some of my tests to break. And that was something I was really uncomfortable with. So I thought the best way to do that is to deprecate those and come up with some replacements that are a little bit more verbose and people can know for sure what's going on. So I added the ones at the bottom. Inherits key and inherits keys which will pass only if the properties are on the prototype but not on the instance. And then owns or inherit keys, possibly the most verbose method name I've ever written in my life, but at least tells you exactly what it's doing, that it will pass if it's either on the object instance or on the prototype. So that stuff. Friendlier test names. So this was a major oversight on my part when I first wrote this. So people are like, I don't really like having the test at the beginning of each of these method names. Test something, test this, test that. Like, it's so old school XUnit, we hate that. Everybody wants these new friendly test names. So I said, OK, sure, I can support that. And what I did in YUI Test for 3 is I introduced this syntax. We could have a sentence, but it had to have the word should in it. Because to me, that would indicate that you were properly explaining what the test was doing. Right? So funny thing, not all programmers speak English. And so if you put in the word should and you speak Spanish, it's really weird. Yeah, so that was an oversight that somebody pointed out to me. I was like, yeah, I got to fix that. So now you can basically do anything like this. Anything that has a space in there, it'll consider a friendly test name, and you can just use it as you would normally. So cool. And then counting asserts is something that was really missing. So in the previous versions of YUI Test, if you had a test that didn't have any asserts, it would pass, because it assumed pass and only failed if there was an assert that threw an error. Now it will do the opposite. So now it will assume fail unless you've done an assert. And if you've done at least an assert and that's passed, then it will pass. So if you have an empty function as one of your test methods, this would pass in YUI Test for YUI 2 or YUI 3, and it will fail from now on because you didn't have an assert in there. And that change alone actually saved me a bunch of time, because I realized that there were a bunch of tests I had written that were written incorrectly, and the way that they were written led to the asserts I thought that were going to be executed to not actually be run. So there was also this kind of hacky thing that I threw in and never went back and fixed called _should. And this was like the advanced test option. So if you had a test that was going to throw an error, my syntax is actually wrong there. So it should be _should, and then there should be error, and then it would be the test name, and then the test error message. So I'll fix that on SlideShare. And that would basically say this test is expected to throw an error, and that's OK. And when it throws that error, you should pass, because I expected it. This is the error message that I was expecting, and if those match, then that's OK. You could also pass in just the constructor of the error if you're looking for a specific type of error, or an error object complete with the message, and it would check both the type and the error message. And so what I did was a recommendation actually from Matt Taylor, who's not in the room, was to create a new assert called throws error that you can pass in the same information as the first argument, so either an error constructor or an error message or an error object with the message that it would compare, and then pass in a function that's expected to throw that error. So at least to me, this reads a little bit better than the old format, because this is right in the test itself, and you know that you're saying, I'm expecting right now this thing to throw an error, and if it's this, then it's OK. And you don't have to scroll back up to the _should section. So hopefully, I'm looking to deprecate all of the _should stuff eventually. This was the first one that I tackled. OK, so what about the versions that already exist? This is also part of the reason I wanted to create a standalone library, was if I could take the core of that and use that as both the core implementation of the YUI Test 3 and the YUI Test 2 versions, then I could basically make updates at any time, and both could get it in similar ways. So all of the tests that used to work with YUI Test for YUI 2 and for YUI 3 will continue to work. So we're not going to get rid of the YUI 3 specific version. So if you want to use the use statement and pull in tests that way, you're free to do that. What it'll be doing is pulling in the core standalone library and then just changing the interfaces so that they match up with what already exists in YUI 3. So these will all still continue to exist, but it'll be much less of a maintenance nightmare for me, because I can just update one core implementation and everything will work. OK, so on to more fun stuff. The YUI Test Selenium driver. The whole point of this is easy automation for continuous integration. So how many people are involved with continuous integration processes? OK, so about half of the people. So the basic idea behind continuous integration is you have builds that are firing off on an automatic schedule. And with each of those builds, you're running all the tests that you have. So that if anybody happened to check something in that breaks the build, you can catch that early on, hopefully by the tests that you're running. So Hudson is a system that we use. How many people have heard of Hudson at least? Cool. And how many people use Hudson? Same people, ironically enough. OK, so Hudson is really cool. It's very simple. It's a Java web application, actually, that is made for continuous integration, continuous development, continuous testing, that lets you fire off things periodically or ad hoc, has some tools for reporting built in. And as it turns out, it's pretty commonly used, as you saw by the number of hands that we had in here. And it kind of started out as something for Java projects, kind of morphed into a more general build system. More information at hudson-ci.org if you want to go check it out. So the question that we had to answer was, if we start out with Hudson, and we want to have tests run in browsers, like how do we fill in this middle piece in here? Like how do we get from there to here? Right? And so I went and I had several discussions with groups inside of Yahoo and outside of Yahoo that were doing continuous integration JavaScript testing and asked them, what is it that you guys are doing? Like, what's the process? What are the tools that you're using? What are the things that I should know about and figure out how to help you use better? So yeah, that was the question. And I started hearing a lot of terms popping up over and over. One more. OK. Go. There we go. So the one that kept popping up was Selenium. And I heard this more often than not, that people were somehow using Selenium, and they were doing it in a bunch of like really incredibly hacky ways to run their tests in all of these different browsers. So Selenium, how many people are familiar with Selenium? First of all, you don't have to be Selenium. But OK, so that was a little bit less than the Hudson group. So Selenium is a web application testing system. It is not designed specifically for JavaScript testing. It's really designed for functional testing. So it's used very heavily by QA departments because they can write scripts that say, go to this web page, do this, verify that this happened, go do this, et cetera, et cetera, et cetera. That's not what I wanted to use it for. What Selenium is really good at is controlling the browsers. So you set up this Selenium server, and by communicating with that Selenium server, you can ask it to tell browsers to do things. And Selenium is excellent at starting up browsers, running a bunch of commands, and then shutting them back down. That's just a small piece of what Selenium does, but that's the reason why so many people were using it to run their JavaScript unit tests. Because they would basically write a Selenium script, say, go to this page that has my tests on it, run those tests, and then somehow get the results. And they were doing all kinds of nasty things to get the results that I won't get into. And it has support for a lot of different browsers. So actually, even more than this, I mean, Google Chrome, Opera, those will all work. The important thing is that Selenium can automate these browsers. I said, OK, people are using that. So their setup kind of looks like this. Right? There's magic that happens in the middle there. Somehow, they end up triggering Selenium. And then Selenium goes off and runs the tests. And then, yeah, some people were screen scraping the YUI console to get results, which was just gross. They just got like a huge bunch of text and then had to parse it. And because it was difficult to parse, they're like looking for, if there's one instance of the word fail, we'll just assume that there's something bad, and we'll cause like a big failure in Hudson, and everybody will go crazy because this one little test broke. So it was bad. So I was basically looking to fill in that gap. And that's what the Selenium driver does, is it fills in the gap between Hudson and the Selenium remote control server. So there are three primary goals in this. So first was that the Selenium driver had to control all of the communication between Hudson and the Selenium remote control server. That there couldn't be any additional steps in there. It had to be that simple to set up. Nobody's reading this, I take it. OK, so the second one was you had to be able to extract as much data as possible from those tests in order for it to be useful. Right? It couldn't just literally be like, hey, one of these tests failed. You guys go figure out which one it is. It had to be much more useful than that. And then third was that we wanted these to work with the already existing tests. We didn't want you to have to make any changes to your YUI 3 test or your YUI 2 test, because that's additional overhead that nobody has time to fix. Right? They just had to work. So the test pages themselves, you're probably used to if you poked around in the YUI source code, is you just start out and you define some test cases or test suites, add it to the test runner, and then run it. So the only thing you have to make sure with the test pages is that the tests will automatically run on page load, because the Selenium driver isn't going to start that for you. So what does it look like? Well, it's a Java utility. And for geek cred, I thought I would throw up the command line options there. So you basically just say, here are my options. There's a bunch of these configurations that you can use in order to fine-tune your build process. Verbose, if you're not really sure what's going on, always very important. You can set up a Selenium host, a port, where you want the results to be put, which browsers you want to run it on, and then the test files that you want to execute. So here are some examples that are only slightly cut off. The first one basically says, I have a test at example.com/test/testui, so go and load that page. So it'll go and do that. It'll do it in Firefox by default, because Firefox is the only one that's available on all of the operating systems that Selenium is available on. So by default, it'll always do Firefox unless you specify otherwise. The second one specifies a Selenium host, where the Selenium server is, and also a port, and then tells it to go and run the tests. This one includes a couple of browsers. So this star Firefox and star iExplore is the Selenium way of saying which browsers to go to. And this is just the very basic way of doing this. So this will take whatever is the version of Firefox that's on your current machine and run it in that. Whatever is the version of Internet Explorer on your current machine and run it on that. You can set up different things to do different browser versions, but that's a completely separate discussion. And the last one here is that we're going to run the tests as specified in this XML file. So --test.xml. And it just looks like this. You say, I have a group of tests. Their base is at this domain, this path. The default timeout for these tests in milliseconds. And then specify the URLs. So this will say example.com/test/test_core, et cetera, et cetera, et cetera. And I set that up because we found out that you might have multiple environments on which you want to test these. And so it's a lot easier to just be able to swap out the base than it is to put in a whole URL each time. And so this is the way that I recommend if you have a bunch of tests that you start to use the tool by listing them out this way. So demo, the part that as a speaker you hope works, because otherwise the point will be completely lost. So this is a Hudson dashboard for anybody who hasn't seen it. And I have one job here called YUI Test. And don't worry, there's nothing super secret in here. This is actually running on my laptop with some sample tests. So look at Project YUI Test, and you'll see a few things here, just for those of you who are not familiar with Hudson. So over on the left, we have the build history. So these are the various times that the build has already been run. Unfortunately, cut off on the left, there are little circles that indicate the status of the build. So there's a yellow if the build succeeded, but there was a test failure. There's a red if the build did not succeed, and a blue if the build did succeed. And what you see over here is the test result trends over time. So this is number of tests that were executed, and then a little teeny tiny strip there for test failures, because of course I had to add in test failures to show you guys what it would look like. But you can also show like just failures. Right, so there was 0, and then there was a bunch because I put them in on purpose for this demo. And this is really useful because you can see with build number 6, I added a bunch more tests. Right, so each build, the build started out doing a little less than 200, and now is doing a little bit more than 500. it's important to know as you're going along exactly how many tests are being executed. And so what I'm going to do, and pray that it works, is I'm going to run these tests right now. So what I did is I took the tests for the cookie utility and the profiler utility, which I wrote for YUI, and I set them up to run on, I think, 3 different browsers. So I'm going to do that right now by hitting Build Now. Actually, goodness in Hudson. You see the little progress bar that appears. It's not accurate, just to let you know. It's just a little animation to show you how far along it thinks it is in the number of steps that you've done. And while it's doing that, you all should introduce yourself to your friends that are sitting next to you. So what's actually doing right now is communicating with the Selenium server that I have set up on my desktop. And it's going and running tests on Internet Explorer, gathering those results back. It's running tests on Chrome, getting the results back. And it's running the tests on Firefox and getting the results back. And so that's all happening and not on this machine on my desktop. Okay, and now it's done. You can see it's yellow, which means that there was a test failure. So I can go in and see what's going on. Okay, so the test, it tells me that my test result has 3 failures. So then I can go in and see what those failed tests are. If there's 3, this test should fail because I set it up to fail. And it tells you the path to the test, which actually the better view for that is here. So what the Selenium driver does is it pulls back the test results in JUnit XML format, which is the worst defined XML format in the history of the world. Like, seriously, if you go and do a search for JUnit XML format, the first result that pops up is, does anybody know the JUnit XML format? Right? It's that bad. It's completely mysterious. So I had to actually go and run a bunch of tests and then get the results back to mimic it. But the cool thing is that Hudson can consume JUnit XML format, and that's how it creates these reports and that graph that I showed you earlier. So by using the Selenium driver, that takes care of all of that for you. It gets all of your results, formats it in JUnit XML format, dumps it into an area that Hudson monitors for result formats, for results, and then starts to create all of these reports for you. So I realized that that alone wasn't good enough because you couldn't really tell at a glance what browser these tests were being run in. So because JUnit XML was really designed for JUnit tests for Java, it has all of this stuff in it for class names and all that Java goodness that we all know and love. And that's what Hudson uses in order to create these names. So as a hack, I decided, OK, in lieu of creating a completely new Hudson plugin, which, by the way, if anybody wants to do that, I'd be happy to work with you on that. I'll just create these fake Java class names so they'll show up here. And so what I did was I started with YUI Test, so just in case you were running any other tests, you could distinguish them. And then just attach the browser name as the next part of the fake class name. So you see like Firefox and Google Chrome and iExplorer there. And then have the actual name of the tests after that. So at a glance, you can tell that, OK, this test failed in Firefox. Of course, it also happens to fail in all the other browsers as well. But if it only failed in one browser, you'd be able to tell that at a glance. Because it would be YUI test.firefox. OK, it failed in Firefox. And you can dig into these to see, these are basically the test suites. And then you can dig in and see the individual tests. You can also see how long it took those tests to run. Dig all the way down. Say, hey, that test passed. Cool. And then it also tells you inside of each suite which ones have failed. So this test should fail. I can go and click on it. And it will give you the actual error message that was returned by YUI Test. This one, it was just an assert that I threw in and said, foo should be equal to bar. So this is the YUI Test error that came back. So with all of that, you're able to trigger all of your YUI tests from within Hudson or any other continuous integration environment and use the tools that you probably already have for creating these unit test result reports. So it can also do TAP, the test anything protocol, if your tools happen to be using that. But to quote Dave Glass, this is huge. Right? This allows you to completely automate all of your JavaScript testing. And you can send this out to any number of servers. You can set up a Selenium grid that acts as like a load balancer across a bunch of Selenium servers. So you can have like some that are doing like IE6 and IE7 and IE8 and do them across a bunch without you actually doing anything. You just make sure that the Selenium server is up. And when this runs automatically, it'll go and do all of those tests for you. So glad that demo worked. So the last piece to the puzzle is code coverage. And this is one of the things that I think a lot of people are still unfamiliar with. So I just wanted to start out with a little illustration of conversations that tend to happen. Is like, oh my God, something exploded, and like, but the tests passed. So what happened? Well, what exactly was it that you were testing? So just because you have tests doesn't mean that you have good coverage of everything that you want to test. So Scotty has that kind of blank look on his face. So I apologize. That was a little bit dumb. But really, we find ourselves in these situations a lot. We're like, our tests passed, but something broke. Oh my God, what's wrong? Well, the problem is you don't have good coverage of the code that you were trying to test. So code coverage tells you what parts of the code you actually executed. And so you ran a bunch of tests, yes, but how much of the code actually ran as a result of you running those tests? And the reason why this is important is because code can have multiple paths. Right? We have a lot of if statements and else statements, so you end up creating different paths through your code. So basically, the previous code ends up looking like this. Right? You start out by calling the function, and depending on the value of that condition, you'll do one thing or another. So this is one possible code path with a flickering cursor. And so it's possible that your test only tests that path. But what about this? There's also this path. And in order to get good coverage, you have to make sure that you're hitting each path in the code. So what are the steps to this? Well, the first step is a little bit of magic. You have to instrument your JavaScript code. So there's no way for me from JavaScript to know that you've executed something or you haven't. So what I have to do is take the code that you've written, do some processing on it, and output a file that has instrumentation in it that tells me when you've executed each of the lines. And so there's a command line utility for that. You basically just pass in your JavaScript file and then where you want the result JavaScript file to be output, and it'll take care of that for you. So the good news is that this is completely safe. There's a JavaScript parser inside of here. And so it parses your JavaScript and then rewrites it in a safe way to include all of this instrumentation. And actually, before I go to step 2, I want to show you an example. So this is what an instrumented file looks like. This is the cookie file. And one of the goals I had with this tool was I didn't want you to have to go back and forth between the original source code and the instrumented file. Because there are some code coverage tools out there that the instrumented code that they output, you actually can't go in and figure out what's going on. Because it's all just like mishmashed together, the comments are all removed, and everything's on one line, and all of that. And that's not incredibly useful, especially if there's some sort of error that pops up. So what I did was I went through a lot of trouble to try to make sure that the code was reasonably close to what your original code was. So there's a bunch of stuff at the beginning that's just setting up some functions and environment variables that I need. And then after that, you see the comments are still intact. And you'll see a few lines have these extra little calls at the beginning. Thank you. But generally, you can still kind of read the code. So with all of these, it just offsets your code a little bit to the right. But for a lot of things, you can still, I mean, especially kind of scroll over a little bit, you can still kind of read your code. So if an error occurred on some line, you can go and figure out what's going on. And so each of these functions that's on each of the lines is what's saying, OK, yes, I executed this line. OK, yes, I executed this line. And you can go through and investigate it. It's not terribly exciting. But it was really important to me that at any point in time, you can open up this instrumented file and still figure out what's going on with your code. So step 2 is you run the tests with the instrumented code. So basically swap out the regular source code that you have, swap in the instrumented code, and then run all of your tests. And so as your tests are running, it's gathering all of these metrics for you as to what exactly it was that you were executing. And then step 3 is generate reports. And that's the fun part. So with the tests that I had on Hudson, I did actually also have code coverage. And because there's no built-in support for code coverage in Hudson, I just had to drop them into my workspace directory. So if I go back to project, every project has a workspace where you can dump files that are related to the project. That's actually where the JUnit XML tests get dumped, and then Hudson picks them up from that. So if I go to the workspace, you can see I've created this coverage directory. And inside of the coverage directory, I have a report. So how many people have heard of LCOV? 2 people, 3 people. Excellent, awesome. So I don't need to explain it. So LCOV is this code coverage tool that was created for Linux. And it's pretty simple. It works off of the same basic methodology as this JavaScript code coverage does. And also has standardized reports for code coverage afterwards. And so I made the code coverage tool use that same format, since it's one, there are a lot of tools that can consume LCOV data. And 2, it's something that people are reasonably familiar with. Well, those people are familiar with code coverage. And it creates some fun reports. Kind of old school HTML, circa 1996 probably. But it's really useful because you can go through. So this is the directory where I had my files. And it will list out the files that you have, tell you how many lines you hit, and also how many functions you hit. And this isn't terribly useful in and of itself. So if you go and click through onto the actual report, what you have is the source code highlighted. So each of the lines that are highlighted in that like grayish blue color are lines that were executed. And next to it, you can see how many times that line was executed. So anybody want to guess why some of these lines have 3? So the very first on YUI.add, you would expect to be run once, right? Why was it run 3 times? 3 different browsers. So as you go through, you can see, OK, so this function was executed, this line of code was executed 3 times. So this is the definition of the function that was being executed 3 times. And then this line within the function being executed 90 times. So this is showing line coverage, by the way, not function coverage. And this ends up being very useful. As you can see, it doesn't matter with the comments, because those aren't executable lines. But what gets interesting is when you find a line that you didn't hit. So none of my tests checked this code path so that I got into that if statement and threw this error. So that's a gap in my tests. That would be good to go back and figure out. And so by going through, you can see, I think I have pretty reasonable coverage in this. Yeah, I have a couple of error conditions that I didn't test. But generally, going back to these reports, you can tell just in a glance which of the code paths you haven't yet tested. So there's also functions where you can see how many times each of the functions were executed. And it's reasonably good at figuring out the name of the function. So if you have an object literal and you have like your method and then the function, it can figure that out. As well as with function declarations, it can figure that out. It only can't figure it out if you're doing like truly anonymous functions where you're not assigning any sort of variable to it or anything like that. But it's pretty good at figuring that out. And then if you're not sure which one anonymous 1 is, you can click on it and it'll take you over to that. So that is the coverage tool. And you can actually programmatically extract the coverage data if you'd like. There's a method called getCoverage on the test runner that returns you an object with all of that coverage information. And you can also format it in JSON format, and that should be xdebug JSON instead of xebug JSON. Yeah, and basically, when you do that, you'll end up with this chunk of JSON data. And if you have that in a separate file, you can also run it through our coverage report tool, and it'll generate either that report that I showed you. There's a couple of other formats as well. And that also is just a command line tool that you give it a file that has that JSON data in, and it'll parse that and generate your reports for you. So the cool thing is that these two tools, Selenium Driver and the coverage tool, were designed to work together. So Selenium Driver is smart enough that when it's running tests, it will check to see if there's any code coverage data there. There won't be if you don't have any instrumented files. But if the data is there, it will pick up that data and pull it in and generate reports for you by default. Yeah, that's what that says. So basically, what we want to create with YUI Test is a complete end-to-end testing solution. And so now all the pieces that we have here allow you to use Hudson, run your JavaScript tests, get your test results back, get your code coverage results back so you can tell if you need to write more tests, just all within the YUI Test system. And so compatibility, the Selenium driver and code coverage all work with these versions of YUI. So the standalone library, also YUI Test for YUI 3.1.1 and higher, and for 2.8.1 and higher. So all of those things will just work right out of the box. And all of this is incredibly awesome. And for people who aren't familiar with testing, I know the first time they get this stuff up and running, immediately they're like, wow, this is like Captain Kirk awesome. So you can contribute. Source code is up on GitHub. On YUI library, it's a completely separate project now, so project/YUI test. That's where you can go to submit patches or file bugs or anything like that. And there is an announcement that went out actually during this talk that has a little bit more information about each of these tools. I want to mention that all of the code in the YUI test project is BSD licensed. So when you go to the YUI library page, and go over on the right rail, there is a link to the license. If you download the source code, not all of the files have that license embedded yet. That's why it's just a beta. We'll be adding that license information in afterwards. It really doesn't matter if you're just going to download it and play with the code. But if you plan on distributing it, you need to add the BSD license to that source code before you share it with anybody else. And again, that will be addressed in the next build that we have. Just didn't get around to it this go around. Just wanted to make sure it's exact same license as all of the rest of the YUI library.